homework hints. So it says here sine series, number A, sine series. So the cosine terms will be 0. I mean the coefficients of cosines will be 0. All ANs are 0 in this case. AN from 0, 1, 2, 3. All we have to find is BNs. Okay. The period is 6 pi. So half of the period is now 3 pi. Because this is 2L. Now we need to find BNs. So BNs are found by the formula 2 over L, 0 to L, fx, okay, sine fx sine n pi x over L dx. Okay, and replace L by 3 pi. So 2 over 3 pi, 0 to 3 pi fx sine n pi x over L dx. Okay, 0 through 3 pi, the function has 3 pieces, so we need to break this domain into 3 parts. So 2 over 3 pi is outside, so 0 to pi, and on 0 to pi the function is 0, so basically nothing. 0 plus pi to 2 pi, so pi to 2 pi, the function, this function is 1 times sine n pi x over L. L is 3 pi, so pi in fact cancel, you can cancel pi and pi dx, and pi to 2 pi. Now finally 2 pi to 3 pi, and 2 pi to 3 pi, the function is 2, so it's 2 sine n pi x over L. L is 3 pi dx. Okay, now integrate these two, then you get BNs, and write down the series. Okay, the series will have only sine terms. Same thing here. In this case it's a cosine series. Cosine series means we will have only cosine terms, so all BNs are 0, and 1, 2, 3, and this is 2L, so L is 2 pi. Okay, that finishes number 1. And number 2 is a f function, that's the integral of f. Show that if this inner function is even, this is given part, then we need to show f is odd. This is a proof in fact. And if inside function is odd, then outside will be even. Okay, basically you can think in this way. Suppose your function is like even function x4th. If you integrate, then we get x5 over 5. So this is even function. Integrate, you get odd function. Other way around, if you start with odd function, any odd function, if you integrate, you get even function. Okay, that's what we are trying to prove in general. What I showed you, just a particular case. Okay, to show f is odd, that means f of negative x is same as negative f of x. We start with f of negative x and get back negative of fx, then the function f will be odd. For even, what we have to show? What we have to show is f of negative x is same as fx. Okay, even function means y-axis symmetry, odd means origin symmetry. Okay, let's I'll show you this one and leave this for you. Okay, let's try to show f is odd. So we start with f of negative x. So f of negative x will be equal to 0 to xx, so negative x ft dt. By the way, in this definite integral, this t is a dummy variable. You can write any, maybe v or u, still you get fx, because f x is coming from here. Okay, so f of negative x. Now to get back to the function, we should have only x, so negative x there. So let's make a change of variable. Let's say t equals some negative v. then we'll convert everything in terms of v. Then dt will be -1 dv. Then going back there, when t equals 0, lower limit 0, when t equals 0, negative v equals 0, so v equals 0. When t equals upper limit negative x, when t equals negative x equals negative v, so v equals x. F of t is negative v, and dt is -1 dv. Now we can pull -1 all the way outside, so we have 0 to x, f of -v dv. Now we want to use the given fact. F is even. Okay, f is even means f of negative anything is fx. Okay, that's the definition of even. Then -0 to x, f of -v is fv back, because f is even function. Now this negative outside, just look at this one. This is same as here, because t is dummy variable. Now we have v, so negative outside, so this is same as, this function is same as fx. Then we started with f of -x, we got negative f of x. That means f is odd. Okay, thus f is odd. F is a odd function, and do the same thing. Okay.